All right, this is Honors Algebra 2 Pre-Calculus. We're doing section 2.7 in Algebra 2, which is transformation of functions, and this is our part 4 video. So, cool. In this video, we're going to put all the pieces together in 3 types of problems. Number 1, graph and identify the transformations from given equations. We've already been doing that in most of our examples, but we're going to go ahead and take it a step up and do ones that have as many as 4 transformations. 2, given a transformation in words, write the corresponding equation. And 3, given a graph of some weird function visually, perform transformations on it. So a couple big takeaways from this section. First thing, changes outside the function are vertical and logical. Changes inside the function are horizontal and backwards. We learned 2 big kinds of rigid transformations, which are adding and subtracting create a slide or a translation. Multiplying and dividing by -1 create a flip or a reflection. Those are rigid. And we learned that multiplying and dividing by a number creates a stretch or a shrink, right? And it's easier for those stretches and shrinks to consider those all to be multiplications. So if, for instance, you had an f of x over 5, it would be smarter to write that as 1/5 times f of x. All right, so we're going to go ahead and move forward and try these 3 types of problems, and that'll be it for our 2.7, and that'll be the end of Chapter 2 in Algebra 2. So, cool. So for our example 7, right, we're going to have an equation, which we have here. We're going to identify the parent function, which would be one of the 4 functions that we have discussed already. We're going to list the transformations in order, and then we're going to graph both the given function and the parent function. Okay, so the very first step that we should address is that we want to know what this parent function is, right? So I'll do the parent function in green just because I inadvertently wrote the modified version in black, which I hadn't been doing. Okay, so the parent function in this situation is either f of x, you can say f of x, or you could just say y. So f of x equals the absolute value of x. The hint that I know that I'm looking at an absolute value is that, oh, hey, look, in the original, there's that absolute value, right? If there were a squared in it, I'd be looking at an x squared. If there's a cube, I'd be looking at an x cubed. If there was a squared, I'd be looking at a squared. So in green, I'll go ahead and graph the parent function. The original is going to look like this. Cool. All right, there's my original. So I'm just going to call that f. That's my parent function. Cool. That's the first thing I was asked. What's the parent function? The parent function is absolute value of x. Second, list the transformations in order. So now this is tricky. So let's start with the fact that there's only one transformation on the inside, right? So the second thing I was asked to do, right? The second thing I was asked to do is to list the transformations. Okay, so let's go ahead and list those transformations in order. So the very first thing that's going to happen is we're going to go right 1, right? That -1 on the inside is going to go right 1. Now, the second and third transformations are up for debate because there are 2 things happening here. There's a negative and there's a 2, right? So it doesn't matter to me which one you call 2 and which one you call 3. So that's why I'm going to write them as 2/3. This order doesn't matter because it really is just a matter of preference, right? So I either flip it first and then vertically stretch by 2, or I vertically stretch by 2 and then I flip it. It really doesn't matter which you do. So, so I'm going to vertically stretch. We're going to say vertical stretch by 2, and then I'm going to flip over the x-axis. Now, because it really doesn't matter if you multiplied by the negative first or the 2 first, it really doesn't matter. These could be in either order. But then, without question, the one that has to happen last is this +3 on the outside, so then I'm going to go up 3, okay? So that's my transformations in order, and then I'm going to go ahead and graph them, right? So just for argument's sake, I'll probably add a different color somewhere in a second so that we can make the vertical stretch a different color, though we'll see. Okay, so let's start in red, right? The first thing we're going to do is go right 1. So my V is going to move to here, and I'm just going to pick a handful of dots for the V, and that'll make the point, right? So all those went right 1. The next thing that's going to happen is it's going to vertically stretch by 2. So what that means is that 0 as a y value is going to stay 0, but a y value of 1 is going to move up and become a y value of 2, and a y value of 2 is going to move up and become a 4. So you can see that this V is getting taller and skinnier, right? So there's my new taller, skinnier V. And then, and I'll go ahead and put this in a different color. I'll go ahead and put this in, I'll put the flip in yellow, right? If I flip over the x-axis, the point on the x-axis stays, but the point that's 2 above the x-axis becomes 2 below, 4 above becomes 4 below, and so on. So there's my upside down with the yellow, right? And then the very last thing I'm going to do is go up. I'm going to go up 3. So if I go up 3 from this yellow point, it's going to be here. Up 3 from here is going to be here. Up 3 from here is here. And so I end up with this upside down, really skinny V, and I'm going to go ahead and graph that in black because that was the color I originally gave. So there's my upside down, really skinny V. Okay? And so that's my G. And again, if you have a bunch of stuff on your picture, you might want to label it the way I did. If you're able to use multiple colors, that's great. Not all of us have multiple colors in our backpack when we're doing stuff, right? Some people are not that organized. I know I am certainly not. Okay, so cool. You're going to try a P7 that's the same idea. So again, remember the first thing you're going to do is you're going to identify the parent function, right? The second thing you're going to do is you're going to tell me all the transformations, right? And then the third thing that you're going to do is graph it, okay? You pause me if you want to pause me, right? So we have h of x equals -1/2 times the quantity x plus 2 squared minus a 3, right? So the first thing I notice is that my parent function is f of x equals x squared, right? The hint is that this thing is a squared, right? So I'm going to graph that here so that I have something to work with. And again, you might not graph this. Like as you're using this in real problems, you're probably not going to graph the parent function, but you're going to have to picture the parent function so that if you were doing this in like calculus, you'd be able to picture what happens to that parent function. Okay, so now when I list the changes, the first thing that's going to happen is this plus 2, right? The first thing that's going to happen is that we're going to move left 2. The second and third thing are two different things, right? So again, which order you write them in is entirely up to you. I'm intentionally going to write them in the opposite order from what I did last time. But these two, it doesn't matter which order you write them in. They're the second and third transformation either way. So I could flip, like this negative is going to be flipping, right? So flip across the x-axis, right? And then the 1/2 outside of the function is going to be a vertical shrink by 1/2, right? And then the last thing that's going to happen is this -3 on the outside, so the last transformation is going to be down 3, okay? Oh, sorry, my bad. Sorry. Stupid clicky pen, down 3. Okay, cool. So again, how much you need to show when you do this is kind of up to you. So first thing I'm going to do is go left 2. So my dots are going to move left 2. I'm going to recreate my x squared parabola right there. Okay, so that's done. Next thing I'm going to do is flip across the x-axis. So with the blue, if you're already on the x-axis, you stay on it. If I'm 1 above the x-axis, I'm now 1 below. And 4 above the x-axis would now be 4 below the x-axis. Okay, so there's my blue. I'll go ahead and use yellow for the vertical shrink by 1/2, right? So the vertical shrink by 1/2 means that I cut each y value in half. So a 0 divided by 2 is still 0. But a 1 divided by 2 is now a 0.5, right? So it's a -1, so it would be a -0.5. It's a -4 divided by 2, that's a -2. So now I have these yellow dots. And then the last thing I'm going to do with those yellow dots is take them all down 3. So this starts at 0, it's going to go down to -3. This was -0.5, so it'll be -3.5 for both of those. This was -2, so it's going to end up being at -5. And those purple dots are going to be my parabola that I'm going to go ahead and graph in black. And you can see how this is a shorter, wider parabola because it is a vertical shrink, which is the same thing as a horizontal stretch. All right, so that's my P7 and E7. Now that's pretty realistic to what you're going to see on an assessment for this chapter, right? That's kind of the whole thing all together, lots of transformations all at once. Okay, cool. Let's talk about E8 and P8, which I've squeezed on one page. So now I'm going to give you a sentence in words with the transformations, and I'm going to ask you to write the expression that has that. So in E8, g of x is the graph of f of x equals the square root of x, so that's my parent function, right? Translated 2 units left and 5 units down. Okay, so 2 units left, right, is going to be plus 2 on the inside, right, because it's left, which is inside, and it's a reverse of what you'd expect. And then 5 units down should be a minus 5 on the outside, right? So what that's going to look like, my answer, is going to be g of x equals the square root of, on the inside, I'm going to have an x plus 2, and on the outside, I'm going to have a minus 5. So that is what my answer should look like. All right, so I want you to try P8. It's the same idea, although I think I actually gave you 3 transformations because I decided to be a little bit trickier. So in P8, h of x is the graph of f of x equals x squared, translated 1 unit to the right, flipped across the x-axis, and translated 3 units up. Okay, so you can pause me if you want. I'm going to go ahead and walk through this. Okay, so the first thing is 1 unit to the right is going to mean that on the inside, I should see an x minus 1, right? So that's what I get first, okay? The next piece of information is I'm supposed to flip it across the x-axis. Well, that's a vertical flip, so that's a negative on the outside, right? And then the last piece of information is I'm supposed to translate up 3. Well, that's a plus 3. So my answer ends up being h of x equals negative of the quantity x minus 1 squared plus a 3. That's my answer. All right, moving on. So now we're going to get to those weird graphs that we're going to see, and we're going to do our last 2 problems, an E9 and a P9, and then that'll be it for 2.7. So let's get to some weird graphs. Okay, so borrowed from the interwebs is this piecewise function graph, and we saw piecewise functions in 2.6, so this is a piecewise function graph. So in all of these, we're going to perform the given transformation and draw the result on the original axes. Now this is already in red, so I have these other ones in different colors. So f of x minus 2 is going to mean move every point down 2, right? So any dot I have, I'm going to move it down 2. So this dot is going to move down 2. This open circle is going to move down 2. These guys are going to move down 2. So I'm pretty sure it's going to look something like, and again, forgive my inability to draw, but it's going to look something like this. Cool. All right. The next one I'm going to do is in blue, right? So this plus 1 on the inside is going to be the opposite of what you'd expect. So it's going to be left 1, right? So now I'm going to take every red dot and move it left 1. So this red dot's here, this guy's here, my open circle's here, my closed circle's here, and the other closed circle's here. So now it's going to look something like this. Now what you're going to notice is this gets to be a lot all in one graph. So there's a chance I'll erase these in a sec to fit the green one. We'll see if we can manage to make it work. All right, for the last one, the green one, this 2 on the inside, right? Remember that's going to be a horizontal, right? So it's going to be a horizontal shrink by 1/2, okay? So what that means is that you do 1/2 times the x's and then the y value stays the same, right? That's what the points are going to look like. So one easier way to do this, and you don't have to do it this way, but it's not awful, to list what the points are. So this was 3, 2, right? This was 3, -2. This was 4, -2. This was the point -1, 2, and this was the point -4, -3, right? So the reason that's useful is because then you can just cut all the x's in half and see what the point should be. So this should now become the point 1.5, 2, right? The x's are getting cut in half. So this should be -0.5, 2. This should be -2, -3, right? The y's aren't getting changed. And these become 1.5, 2, -2, and 2, -2, right? So when we draw these, this point, this red point, is now going to be right here, right? It's going to be -2, -3. This point is now going to be -0.5, 2, so it's going to be half that distance there. This point is now going to be at a 1.5, 2. This point is now going to be at a 1.5, -2, and a 2, -2. So what's going to happen? Oh, sorry, I made this one so frustrating when I accidentally make something an open circle and I wanted it to, or a closed circle and I wanted it to be open. There we go. Okay, there we go. Open, right? Because that was an open circle. Well, okay, so if this happens to you, just write, hey, Hogan, it's open, because it happens. We don't mean to, but we accidentally. All right, so it goes this way and this way, and see how skinny that little graph is, right? See how it was made skinnier. And again, I'll try my best to make that a little open circle. Cool. All right, so that's my shrunk graph, right? So you're not gonna have to do this a lot, but you can see that that is narrower, right? It is pushed in from the sides. It is the same physical height that it originally was, but it is narrower, pushed in towards the y-axis. I'm not gonna give you a ton of these in general, but it's a good idea to know how to move stuff around if I give you a sort of abstract function like this that's not one of the memorized parent functions that we know. All right, so we're gonna try an E9, and then that's gonna be it for this video. All right, so for E9, again, borrowed from apparently mathbits.com on the interweb, I found this piecewise graph, right? So you're going to go ahead and perform all these operations if you have a color, I'm going to do it in the color that I'm doing it in. If you didn't have that, you would just label them clearly on your graph, right? So first thing I'm going to do, f of x plus 2 is going to be up 2 because that 2 is outside the function. So in black, I'm just going to move each one of these dots up 2. And I'm going to end up with a graph that looks like this. Okay, and again, if you didn't have multiple colors, you might just put an A next to it, right? Something like that to make it clear, hey, that's graph A, right? You could put a little A next to that too, because that was the A of the graphs. All right, so f of x minus 3, well, that's going to move right 3, right? Because it's an inside change, which means it's backwards and horizontal. So I'm going to take the original blue graph, and I'm going to move right 3. So this dot is now here, which is right 3. This dot is now here. This dot is now here. And this dot's now off the thing, but we can kind of anticipate that it's going there. So there's my red graph. And again, that's my graph B. This is not an easy one to label if you were trying to label this without colors, but conveniently I was able to draw them with colors because of this lovely program. And then the last one has a 2 in front of f of x. So what this is going to do is this is going to be a vertical stretch by 2. Now, I think most of us are naturally better at this without listing the points when we talk about x's and y's. It's easier if you're just altering the y. So you start at this point and you say, hey, I need to double the blue point. I need to double the y value. This y value was -2, so now it's -4, right? This y value was 2, so now it's +4. This y value is -1, so now it's -2. This y value was -3, so now it's -6, which is sort of down here-ish. Right? And what you're going to see is that this graph got taller and skinnier. You can ignore that little stray mark I accidentally made a second ago. So again, also my inability to draw straight lines on this particular program. Okay, so that's supposed to be a straight line, but you get the gist. Okay, and that's my graph C. And so that's kind of the idea of how you take this function. Now, what you'll see a lot of times, and if you look at the one that's in the textbook, the one that's in your textbook is more of a function that looks kind of like this. Like they give you one like this with these clear points. And then they have you move that weird shape up, down, left, right, flip it over, et cetera, et cetera. But that's kind of the gist of how this works. So that is transformation of functions. And that's the end of our Chapter 2 stuff in Honors Algebra 2 Pre-Calc.